Guys, welcome to another video. Welcome back to our YouTube channel, your YouTube channel, The Beauty in Math and Physics. Today we have another interesting problem on limit of a function, something very special. So let's write together with the solution. We are to evaluate the limit as s approaches or tends towards 0 of this function here, 1 upon x minus 1 upon x into the square root of s plus 1. For every problem on limit, it is customary we test. Now, if I plug s equal to 0 in this first, variable here, I will have 1 divided by 0. That will give infinity. For the second one, I will have 1 divided by 0 multiply the square root of 0 plus 1. And if 0 multiplies anything, it becomes a 0. So we also have 1 divided by 0, which is infinity. So in both cases, we are going to be having infinity minus infinity, which is indeterminate. So hence, we have to use algebra or use the L'Hopital's rule of differentiation. Now, for this particular problem, I would love to use algebra because for someone who is not well grounded in calculus, to differentiate 1 upon x, that's quite very easy. But to differentiate 1 upon x into the square root of s plus 1, that may be an Herculean task. So hence, I'm using algebraic simplification, which is a better alternative. So we are going to have something like this solution. Limit as s approaches 0, 1 upon x minus 1 upon x into the square root of s plus 1. Now I will take the LCM of these two denominators. So as you can see, s can actually divide this. So the LCM is s into the square root of s plus 1. So if I use x just the way we do fractions, we will do basic operations of addition and subtraction in fraction, the same thing we do for algebra. So if I use s to divide this s into the square root of s plus 1, square root of s plus 1 is left and multiplied by 1 to be square root of s plus 1. Then if I use s into the square root of s plus 1 to divide s into the square root of s plus 1, I will have 1 left. 1 multiply 1 will give us 1. So this is what we are going to have. Now I will write this step again. So limit the square root of s plus 1 minus 1 upon s into the square root of s plus 1. So as s approaches 0. Here, I've been able to actually combine these two fractions together to have a compound fraction. Then I want to see test whether if I plug in x equal to 0, whether it will be determinate or indeterminate. Now, square root of 0 plus 1 is square root of 1. 1 minus 1 is 0 for the numerator. Then for the denominator, 0 multiply whatever will come out of here is going to give us 0. So we have another case of 0 divides 0. So that will be an indeterminate form. Hence, we need to progress by rationalizing the sort. If you look at the fraction we have here, the square root of s plus 1 minus 1 upon s into the square root of s plus 1. I cannot rationalize the denominator of this sort because the sort at the denominator does not have a conjugate. Therefore, implies that I can only rationalize the numerator of this source. Now, the essence of rationalizing sorts or radicals is to enable us to have rational, variables or expressions that can be flexible and tailored towards our objective. So, rationalizing the denominator is not going to make any sense. Like I said, the denominator of this sort does not have a conjugate. But if you look at the numerator carefully, we have the square root of s plus 1 minus 1. So the conjugate of this sort is actually the square root of s plus 1 plus 1. Then I'll also multiply the denominator with the square root of s plus 1 plus 1. So this sort has been rationalized by multiplying both the numerator and denominator by the conjugate of this sort, square root of s plus 1 minus 1. So if we move forward, what we see on the numerator here is a difference of two squares. One of the most powerful tools in algebraic simplification and factorization. So we are going to be having limits as s approaches or tends towards 0, square root of s plus 1 all squared minus 1 all squared upon, here we are going to be very careful with the denominator. Now I would love to take this s out of the parentheses. So I will take s out, open the parenthesis, write the square root of s plus 1, close the parenthesis, and open another parenthesis, the square root of s plus 1 plus 1. So this is what we have at this level. Now, on the numerator, that's quite very easy. The square here, we undo the square root. So the next step is going to be limits as s approaches or tends towards 0. We'll be having s plus 1 minus 1 upon, like I said, we are going to pay closer attention to the multiplication or distribution at the denominator. Now, s is already factored out, so I will still take it out, open the parenthesis. Here, the square root of x plus 1 multiply the square root of x plus 1. And when like sorts multiply each other, the square roots will annihilate. So we are going to be left with s plus 1. Then I continue with the distribution process. If I use the square root of s plus 1 to multiply 1, I will have the square root of s plus 1. Thus far, we have done very well. Now, on the numerator, 1 minus 1 is 0. So that takes us to the next step. We have limits as s approaches 0. 1 minus 1 is 0 on the numerator. We have only s left there. Upon x at the denominator, I will also open the parenthesis. Then, okay, nothing to really factorize. I'll write everything in the parentheses as usual. I'll close the parenthesis. As you can see carefully, this s on the numerator will annihilate this s on the numerator. So we are going to be having limit as s approaches 0 of 1 upon s plus 1 plus the square root of s plus 1. So at this level, we can now plug in our limiting value and get our answer. So if we substitute s equal to 0 into this expression, that's going to give us 1 upon 0 plus 1 plus the square root of 0 plus 1. Now, what we have done here is very simple. Anywhere we see x, we replace it with 0. So this s is actually a 0, that's what you are seeing here. Then the 1 here remains intact. Then the square root sign is carrying x plus 1. So you have 0 plus 1. So this is going to give us 1 upon 1 plus the square root of 1. And square root of 1 is 1. It will be 1 over 1 plus 1. So at the end of the day, the answer to this problem is half. So folks, we've come to the end of our another interesting tutorial. Now, I guess you enjoyed it and you understand what we have done here. Please don't forget to put your comment, like this video, give it a thumbs up, share it with your learning friends and colleagues. See you next time. Bye.